Dr. Crispin Little, I welcome you on our SOPHIA studio for a small conversation about your work and the work of your colleagues on the session that you have been sharing on the Deep Sea Biology Symposium. And you are a full-bred scientist from the Leeds University in the UK.
That's correct.
Okay, thank you. And I see that your session was basically devoted to the evolutionary history and fossil records. So paleontology.
That's correct, yes.
Yeah. And when we think about paleontology, we think about big creatures, dinosaurs, and so it's the common folk. And in your case, where are your dinosaurs? They are big ones in the deep ocean, in the dark abyss, or they are something smaller and different? Please tell us about that.
So yes, actually most of the fossil record comes from the marine realm, and of course dinosaurs didn't live in the sea. Yeah. So there are related animals that did live in the sea, like plesiosaurs and ichthyosaurs. But in fact, most of the record of the fossils comes from small animals, so things like bivalves and gastropods and crabs and shrimps, because those are the dominant animals in the sea, and of course that's what we see in the fossil record as well. So from a perspective of the deep sea faunas, many biologists will tend not to think so much about the evolutionary history of the animals that they're working on, or if they do, it's from a perspective of genetics. But we can actually look at the actual fossils from the deep sea and then to ground truth what the biologists think about their evolutionary history. So for those of us who are working in the marine realm, in the sea, from the deep sea paleontological perspective, our animals tend to be rather small and not large with big teeth.
Yeah, thank you. And in this case, the animals, the paleontology of the deep sea animals, I would say that we have started making their history, the natural history, the other way. Because traditionally we had investigation on fossils, and then came genetics. And with deep sea, we start with genetics, so to speak, and then we go back to the fossil record for ground truthing.
Yes, and particularly to get estimates of dates when animals first appeared. So it's very important to look at the fossil record as well as the genetics, because the genetics can only tell you about the evolutionary history of living animals, but they can't tell you about what was actually in the sea at the past, because most species become extinct. Yeah. But we can actually look at the deep time history of groups of animals, and we can say, yes, this hypothesis makes sense, no, this hypothesis doesn't make sense. So a meeting like this is fantastic, because then we get the opportunity to talk to people who are working on deep sea biology, and we can think about hypotheses and ideas, and we can say, well, yes, this is something that we can help with in the fossil record. And sometimes the things that we find in the fossil record do not reconcile easily with the things that the biologists are finding in the deep sea.
Yeah, it's amazing. It's another challenge. One of the amazing things of science is that when you find one answer, usually you have two more questions.
Two more questions, that's absolutely right, yes.
And stimulating.
Yes.
And also another thing that has been puzzling lots of people, myself included, is where do those organisms come from? They have evolved. Now they are living in the deep sea, but their family history relate also to the deep sea, or they have evolved in other environmental areas.
Yeah, so traditionally people would think that animals moved from shallow water into the deep sea environment, because the idea was also that the deep sea was much more challenging sort of environment because of pressure, because of the lack of light. But in fact, it's becoming more apparent now that there are groups of animals which have always lived in the deep sea, and maybe that some animals have evolved in the deep sea and actually moved on to shallow water areas. So we have in the fossil record, for example, many examples of animals which in the geological past lived in shallow water environments, and the stalked crinoids, the feather stars, are an excellent example of that, where it's very common to find those in shallow water deposits, but today they're only found at 200 meters or greater. So the idea was that they evolved in shallow water areas and then moved offshore. But in fact, some of the things we're finding in the fossil record now shows that they were also living in the deep sea in the past as well. It's just that the record that we have of truly deep sea sediments is poor in the geological record. And the reason for that is that it's difficult to get deep sea sediments up onto the land, which is where us paleontologists work. So there are very few sorts of conditions that allow that to happen. So largely our fossil record is very much biased towards shallow water marine sediments.
Where collecting is much easier and has been done over the last centuries.
That's right, yes. So the vast majority of the record is from shallow water, but occasionally there are places where we can find truly deep water sediments, but it's by investigating those that we can really start to get a good handle on what the ancient history is of the deep sea animals.
And what about the places where you find now your specimens from the former animals in the deep sea?
Yes, so those sorts of circumstances are particularly where you have continents colliding, and when the continents collide, the sediments in the deep sea between them sometimes get pushed up onto the edge of the continents. And a good example of that might be, if you think about the Himalayas today, is that there are marine deposits, for example, almost on the top of Everest. And those deposits came from the sea that was between India and Asia. And then when India slammed into Asia, it actually pushed some of these deep sea sediments, and now on top of some of the highest mountains in the world. So it's incredible. So particularly those sorts of circumstances are where you can have really deep sea sediments being pushed up onto the land for us to investigate.
It's an amazing perspective into the origins of life and the way it has been moving around in space and time on our planet.
Yes. So that's another thing that we were trying to show in our session as well, is that many things that you think about modern deep sea biology, or the shape of the continents, the position of the ocean basins, the circulation in the ocean basins, and even the concentration of major elements in the oceans. Everything was different in the past because of plate tectonics, means that the continents have moved around, ocean basins have opened and then closed and been destroyed, and also we know now that some ocean chemistry was different as well. So almost everything was different, and you can't really get a sense of that by looking at the distribution of modern animals. You actually have to look back in the past. So the longer that you think you have an evolutionary history of these animals, the more different the conditions were that these animals were living in. So as I said in my opening talk, the present is not a very good key to the past, and you really have to start looking at geology to understand what the past conditions were like for these animals.
I think it's a very inspiring work. You are in fact putting time in the study of life. You do not study it any longer in 3 coordinates. You study.
Yeah, so you have that fourth dimension.
Yes,
Yes.
time.
Yeah.
That is the key to understand.
But of course, there are also downsides to that as well. For example, many of the things that are very interesting about modern biology, particularly related to the revolution in genetics that we have now, is something that we just cannot work with in the fossil record, because all we have are the remains of the animals, maybe shells from mollusks, but we have no soft tissue of the animals, so we cannot investigate things like population genetics, which is so very interesting about modern marine communities. So there are positives, but there are also some negatives from a scientist's point of view.
Yeah, but maybe solutions will come in the future.
Yes, you should never say never with science.
Okay, we were delighted to have your views on these issues, and also to have your expertise on our training program. So I wish you everything goes very well with your work.
Thank you very much.
Thank you. Thank you.